In this chapter, we will talk about allowed spoke lacings, tangential forces, and radial spokes and crossing spokes.
There once was a man from Fort Worth who had a big wallet and girth. He loved the French tour, and that led to the lure the lightest of bikes to unearth. He thought, I'm a world-class cyclist, might have a shot as a finalist. He got some good deals on some low spoke count wheels. When they broke, he became a survivalist. The two DVDs I have on the market that cover exhaustively how to build a bicycle wheel cover extensively the different lacing options, but in this video here I want to at least give you a little bit of a summary because it's important to have that to get a little bit more deeply into the physics and engineering of how the wheel works.
When we're looking at the number of spokes and the crossing pattern options, there's a rule that we have to go by, and it's this. The minimum number of spokes for X crossings, where X is an integer, is equal to X times 9, rounded up to a multiple of 4. Now, the only way to understand that is to provide some examples. And we'll make a little table here, crossing pattern and minimum number of spokes to use that crossing pattern. If I want to use a 4-cross pattern, I have to have a minimum of 4 times 9, which is equal to 36 spokes in the wheel. If I want to use a 3-cross pattern, I have to have a minimum of 3 times 9, which is equal to 27, which I round up to 28. I have to have at least 28 spokes in the wheel to use a 3-cross. For a 2-cross, I have to have a minimum of 2 times 9, which is 18, which I round up to 20 spokes. For a 1-cross pattern, I have to have a minimum of 16 spokes. And for a 0-cross or radial, there is no minimum. In each of these situations, with the exception of the last one, the product, or the number that the product is rounded up to, that is 36, 28, 20, and 16, are all multiples of 4. The reason for these limitations is to keep the spokes from interfering with each other, which I will now explain by showing you why you can't do a 4-cross on a 32-spoke wheel. I have put in the first 2 sets of spokes and twisted the hub, so I'm ready to now begin putting in the crossing spokes. 16 spokes of the total of 32 have been put in so far. This is a 3-cross pattern, and that is the crossing spoke. It crosses that spoke, and that spoke. Importantly, note that the crossing spoke does not touch or interfere with the head of the adjacent spoke. In a similar fashion, the next crossing spoke will miss touching the head of the adjacent heads-out spoke. This is the same wheel laced up as a 4-cross. There is my crossing spoke. Now I cross 4 spokes. That's the first, second, third, and fourth. But look what's happened at the hub. Here I have this hole here is where the next crossing spoke is going to come out, and it's going to lie either under or over the first crossing spoke that I just put in. My next crossing spoke will look like this, and you can see what's happening. You can never have spokes lying on top of each other on the same flange. Let's look at hub and rim hole drillings and see what's appropriate for front and rear wheels. Once again, a little table, holes, the front wheel and the rear wheel. And we'll start by looking at all the different possible numbers of holes, and we'll tentatively say that all of those are good for the front wheel and for the rear wheel as well. However, in reality, when we look at an 18-hole hub and rim, we cannot use that in the rear wheel, so that leaves us there with our final options. Just to summarize some of this, if you want to make a 48-spoke wheel, you could do a 5-cross because 5 times 9 is 45, but 4 crosses is plenty. You don't really need to do a 5-cross. If I have 40 to 44 spokes, I could do a 3-cross, but I'm going to stick with my 4-cross here because 4 crosses will make the pulling spokes more tangential than 3 would. If I have a 36-spoke wheel, as we said before, that's the minimum number for a 4-cross, so I could do a 4-cross if I want to, but a 3-cross is going to give me shorter spokes, better angles, so I would do a 3-cross with a 36-spoke wheel. Well, I just referred to a spoke being more tangential. What does that mean? Now, using this wheel here as an example, let's define what we mean by tangential spoke lacing and what does that actually mean and why is it important. If we're looking at the drive side of this wheel and we turn the hub clockwise, then a spoke like this pulls the rim clockwise also and makes the wheel turn, and you can see that that spoke there is tangent to the flange of the hub. More specifically, the spoke is tangent to the circle of holes in the hub flange to which the spokes attach. The torque exerted on the rim by this spoke here is equal to the force applied times the arm, which is the radius of the hub to the whole circle diameter, times the sine of that angle theta. The symbol for torque is the Greek letter tau. There's the formula. The force will be measured in newtons and the radius in meters. There's my diagram expanded a little bit in the upper right. This is the familiar sine curve, and notice that the sine is at its maximum at 90 degrees. So therefore, the torque is at its maximum also at 90 degrees, which is what you see in the picture. Here's my 28-spoke wheel with a 2-cross. Same force, same picture, except a different angle of the spoke. Same formula for torque. Here's my close-up. I see that angle theta is a bigger angle than it was before. If I look at my sine diagram, I see that the sine has started to go down. With the sine being smaller, so will the torque. Here's my same wheel with 28 spokes radially laced this time, and here's my close-up. We see that my angle is 180 degrees. At this point, 180 degrees, the sine is 0, so there's no torque transfer until the hub turns far enough to generate some type of an angle. Ideally, for any wheel that has to transmit torque, I would want theta to be 90 degrees because that is when the sine is at its maximum. If I carefully label these lines, RH is the radius of the hub, L is the length of the spoke, and RR is the radius of the rim. The only time theta will be 90 degrees is when this equation here exists, and you'll probably recognize that as the Pythagorean theorem for a right triangle. When you're building a wheel, you certainly have a lot of decisions to make. You have hole drillings, crossing patterns, and so on. But you should be aware of the fact that you need to figure out a lacing pattern that will give you an angle that comes as close as possible to 90 degrees for good torque transfer. If I'm building 32-spoke wheels, I have 2 options. If I have a narrow depth rim and a small flange hub, I'll probably get the best results with a 3-cross. If, on the other hand, I have a deep rim and or a hub with wide flanges, I'll probably get the best results with a 2-cross. The 2-cross will be stiffer. This is a judgment call, and I'll illustrate this with some examples. We're going to build 2 wheels for comparison. Here we see 2 Shimano 105 hubs, and here we have laced those up to Velocity 823 rims. The wheel on the left is a 32 spoke as well as the one on the right, but the one on the left we're going to lace up as a 3-cross, and the one on the right we're going to lace up as a 2-cross. I'll explain this a little bit more in the next chapter, but trust me for now that when you do some calculations and you figure out what's called the side-to-side stability of the wheel from calculating bracing angles, I get forces like this, and you can see that the rim on the right using the 2-cross has a little bit more lateral stability than the wheel on the left. And that is going to make the wheel on the right with a 2-cross stiffer and give it less side-to-side rim movement. Now let's remember that we're only looking at one pair of spokes. There are 16 other identical pairs. And so if we compare the difference in the tension and we multiply it by 16, suddenly we get 3.5 kilograms of force, which is nearly 8 pounds. So the additional lateral stability of the rim that we get from a 2-cross compared to a 3-cross, everything else being equal, suddenly becomes significant. And back to our summary, if we have 28 spoke wheels, we once again have two options. We have exactly the same situation as we had with 32, depending on our choices. We can go with a 3-cross or we can go with a 2-cross. The 2-cross, as we saw, is going to be a little bit stiffer. If I've got a wheel with 24 spokes, let's do a 2-cross. If I have a 20-spoke wheel, let's once again do a 2-cross. If I have 16 spokes, I'm limited to a 1-cross. We can also try something that we could call mixed lacing. Let's say you're going to build a 28-spoke wheel, and you know there's some benefit to a 3-cross, but you know there's some benefit also to a 2-cross. This is not hard. You just have to pay attention when you're lacing up the wheel and make sure you calculate the spoke lengths correctly. I'm going to do 2 spoke length calculations, one for the 3-cross and one for the 2-cross. When I run my calculation for the 3-cross, I find that I need spoke lengths of 290 millimeters on the drive side and 292 on the non-drive side. When I do the same calculation for a 2-cross, I come up with 280 and 282. I know that the 3-cross pattern will give me spokes that are more tangent, but the 2-cross pattern will give me better bracing angles of the spokes and a little bit more side-to-side stability. But I can have it both ways. On the drive side, I can do that as a 2-cross and use my 280 millimeter spokes to give me a better bracing angle, whereas I can get more tangential lacing on the 3-cross pattern on the non-drive side by using the 292. So those would be your 2 spoke lengths to have a mixed lacing of a 2-cross on the drive side and a 3-cross on the non-drive side. Obviously, that was a hypothetical calculation, so you have to do your measurements and a calculation is accurate for the components that you're using. People like radial lacing because radial lacing looks cool, but there's a lot of information about radial lacing that is incorrect. People will say you can do radial lacing on the non-drive side, but you can't do radial lacing on the drive side because the drive side has to be able to transmit torque. But this is incorrect because the hub flanges do not turn independently of each other. So in reality, either side of the rear wheel can be radially laced, but not both sides at the same time. Radial lacing gives you shorter spokes and a stiffer wheel and less side-to-side displacement of the rim. Radial lacing really has more to do with the hub because if the spokes are pulling straight out, then there is less metal in the hub flange to support the pulling force of the spoke. And so radial lacing can be stressful on the hub, and you have to make sure that you're not exceeding a manufacturer's warranty and therefore voiding it if you do radial lacing. I said before that we can't use a hub and rim that have 18 holes in a rear wheel, and that's because 18 is not a multiple of 4. So if you're using 18 spokes, it means you have to have radial lacing on both sides, and therefore it's inappropriate for the rear wheel because there's no capability of transferring torque. This is one of those Zipp wheels, and if you look at it, it's a beautiful wheel with a Zipp Firecrest rim and Sapim CX-Ray spokes. Notice that the drive side is radially laced, and on the non-drive side we see more of a tangential lacing of the spokes. Sometimes we don't have as many lacing options as we think we will. This Zip 303 Firecrest rim with 24 spokes is a good example. It's a rear wheel and we're looking at it from the drive side. If we look at the drive side flange, we see that this spoke is a straight pull spoke. This one and the other 11 spokes like it have to be laced radially. This is the non-drive side of the same wheel. If I look at a close-up of the hub, I find an aluminum cap here, and if I remove that little cap, I can see that all these spokes are straight pull spokes as well, and because of the orientation of the way the hub is cut, I'm limited to a one-cross pattern. So I can't do a two-cross pattern with this hub, even though I have a wheel with 24 spokes.